In this lesson, we will discuss the Moody chart. The Moody chart's primary purpose is to provide a graphical representation of the Colebrook equation. Before inexpensive computers became widely available, it provided a means of quickly estimating the Darcy friction factor F. The Moody chart shows the value of the friction factor as a function of Reynolds number for various values of the relative roughness. Notice that the x and y axes both use a log scale. If the Reynolds number of a flow is below approximately 2000, the friction factor is only a function of the Reynolds number and can be calculated directly from the formula 64 over the Reynolds number. This formula is represented graphically by a line on the left side of the Moody chart. If the Reynolds number is between approximately 2000 and 4000, the flow is in the transitional regime. There is no accurate method of determining the friction factor for this range of Reynolds numbers. Most of the Moody chart is dedicated to the turbulent flow regime, in which the Reynolds number is greater than 4000. Recall from the Colebrook equation that the friction factor for turbulent flows is a function of both Reynolds number and relative roughness. The only way to plot a function of two variables on a two-dimensional graph is to hold one variable constant while varying the other. In the case of the Moody chart, the Reynolds number is varied while holding the relative roughness constant. For example, suppose the pipe you are examining has a relative roughness of 0.002. You would use the curve shown in orange to determine the value of the friction factor at different Reynolds numbers. Now suppose the Reynolds number of the flow is 10,000. Draw a vertical line from 10,000 on the x-axis until it reaches the orange line. Now draw a horizontal line from the intersection point to the y-axis and read the friction factor. For this example, the friction factor is approximately 0.032. Moody charts only show curves for a limited number of relative roughness values. In this particular chart, curves for 18 relative roughness values are presented. When you encounter a pipe flow problem in which the relative roughness is not shown on the Moody chart, a rough interpolation between two adjacent curves usually will suffice. For example, if the relative roughness of a pipe is 0.0015, you can estimate a curve between the 0.001 and 0.002 curves. Although this method introduces some additional error into the value of the friction factor, the error is usually relatively minor compared to other potential sources of error, such as uncertainty in the actual value of the roughness. It is important to remember that frictional losses occur in all pipes, even if they are hydraulically smooth and have very small relative roughness values. Pipes made of glass and plastic are examples of pipes that are hydraulically smooth. For these types of pipes, the friction factor is found using the lowest curve on the Moody chart. At relatively high Reynolds number values, notice that all the curves become horizontal, which means the friction factor becomes a very weak function of the Reynolds number. We call this flow regime wholly turbulent. Physically, it represents a flow where the size of the viscous sublayer has been reduced to the size of the roughness.